All right. Well, thank you, Brian. And thank you, Dr. Shuman. That was a really good overview of how we're actually using satellite imagery and this aerial view to track trees over time. And what I wanted to point out is that you know, you don't have to be an expert like Dr. Shuman to actually start looking at changes over time. There are a couple tools out there that have facilitated this, made it a little bit easier. And so, as was pointed out, you know, there are certain scales, what we can actually see, and that we want to keep in mind. And sometimes it's important to recognize that technology changes, but there's ways that we can actually use some of that 1984 sort of blurry images to actually understand an area. And so one of the longest running satellite projects is the Landsat mission. And so that really does give us this 1984 to 2018 view. And so in the chat, I dropped in a link to one of the tools that Google has put together, which allows you to go to a location and time travel. So here we are looking at the Goddard Space Flight Center visitor campus that we were looking at earlier. We can see the white tops of those buildings that were created. And so that's obviously very different than the brown that we see of the dirt and the construction, right? And so that's what it looked like in 1984. In particular, I want you to see some of these, the tree cuts that Dr. Shuman also pointed out. So the nice thing is you can zoom to any location on Earth, but here, if I actually just play through, we start to see an animation of annual changes over time. And obviously, many of us were very young when these things were happening, but we can see the buildings, we can see these sort of changes over time. And importantly, being able to compare this 2018 to 1984 allows us to really get those differences, right? And so, you know, we can't count the individual trees here, but we can see the places that we want to go measure, right? And so just doing this comparison can really help you to localize what's happening in your local area so that when you do go out and make tree height measurements, you have a sense for the age of those trees. Because you can use a tool like this to actually time travel, go back and forth. And it's just amazing the patterns of houses and why did they build the houses in some of these weird shapes that they did, right? Great sort of questions to investigate compared to some of these big tracts of intact trees, right? So this is where these on the ground photos really can help us, us as scientists, but also you to understand this aerial perspective. Because it's very different when you go to the ground, go to these locations, like what Dr. Shuman was showing. What do those trees really look like? So I want to encourage you to go and explore this tool because the nice thing is you can actually share this with other people. You can share the direct link, like what I did in the chat window, directly to this location. Or if you have a web page or a blog, you can actually embed this view into your web page so that other people can see this and see what's happening in your local area. And then give us some context. How big are these trees? What type of trees are they? Do they lose leaves at any time of the year? Or do they stay green throughout the whole entire year? Because importantly, we don't know what date, what month this was actually taken, right? Google's not sharing that. They're just saying that this is what it looked like in this year. So that date can really tell us whether Google did this right and they're actually showing us what the ground conditions look like. It's green or not green. Right? So there's a lot of, I have a lot of fun with this tool because you can go anywhere in the world and explore and do a comparison to maybe another globe school or some of the other research that's out there. So this is a really fun and exciting tool, and I've shown you over the last couple of Trees Around the Globe campaign webinars, a couple of these tools that allow you to time travel. So this Google one is actually pulling data from NASA and the U.S. Geological Survey, who managed the Landsat mission. So, so hopefully they'll add to this and we'll get a 2019. But that's a fun one to explore. But I also want to highlight, because it is helpful to get onto the ground and actually see what it actually looks like. So if you're not aware, Google has added basically they're taking taking Google Earth Pro, which is on desktop, which is what Dr. Shuman was using to view his data. Now in Chrome, in the Google Chrome browser, they have the same Earth data, and you can actually go to places and explore this in 3 dimensions. So I want to highlight this because here's the Goddard Space Flight Center Visitor Center. And so here you can actually see kind of how big these trees are in this location. Importantly, you can actually see the rocket that they have out there. I was really excited to see this cell tower that is closely associated there. And so this is actually a really neat way that you can get in and start to kind of get that 3-dimensionality, similar to if you actually went on the ground. But I want to highlight that the data is not complete.
Yes.
Here we are, only half of the buildings or trees at that location have this 3-dimensional height to it. So this is the ongoing science that we're doing, but it's really exciting because you can actually zoom in and navigate around just like you are in Google Earth, and you can spin around. And what I want to highlight is you can get a profile similar to what Dr. Shuman was saying of those heights of trees. So again, it gives you a way of connecting what you're doing out on the ground to some of these neat visualizations, because you see how tall this cell tower is over those trees, right? They're almost twice as high as those trees. So that just gives us some interesting things to go explore. And as I go through, we can actually start to get a sense for an intact canopy and some of the data that Dr. Shuman was showing us. And then importantly, here we are, we actually drop down, and the roads that he was showing us earlier become very obvious. The size of the buildings in relation to the trees. So this is where we're going. And over the next several years, you would expect to start to see, not just seeing things from the way, the way that we've been looking at it, straight down without that structure that we're used to seeing, to now all of a sudden having this 3-dimensional way of looking at our landscapes. So to me, this is really exciting. And the activities you guys are all doing helps us to understand this, and you can use these tools yourself. So with that, I wanted to show you those kind of exciting things. And so go out and record some of these observations and do some of these measurements so that we can track these changes that are happening out there.
That's great, Peter.
Yep, take those measurements. Start taking them now if you haven't already. Continue taking them if you have already started, and then definitely in April, take as many as you can. So this is going to be amazing stuff. So excellent. So this could be, here's a little question for you in the chat, Dr. Shuman. It says, how do trees affect the weather? It's a loaded question right there, but.
Actually, Jim Tucker gave an interesting talk in H114, the big conference room down here not too long ago. And one of the things he mentioned was that the work that he has done over many decades of research has been to illustrate the importance of understanding the vegetation cover as it takes in and gives off moisture. And so, not sure that I can speak to how trees affect the weather, but they certainly help cool the surface. They certainly take in moisture, absorb it, and release it as they essentially live and breathe. And that helps basically moderate the weather systems as they come and go. And so for one of the things that Compton, Jim Tucker mentioned was that when they tried to model the atmosphere with a static ecosystem, the model didn't work well. They had to put a dynamic ecosystem in order to get the climate model results to work better. So the trees are definitely part of the system that we're all living in and are an important part of that system.
Excellent. Yeah, great response for that. Yeah. Have one more question here, and it's kind of a, says, were you able to gauge the impact of deforestation, the extent of its impact to a certain demography? Just trying to figure out the actual context of the question.
I can hop on that one, Brian.
Okay. Thanks, Peter.
Because this connection of land cover change, in this case, tree cover, and who's living in that location is a really big question. And so one of the pieces is that we first have to do is just map out where things are changing. And that's just the first thing that we need to do. And once we've identified where things are changing, then we can start asking questions about how that affects the people living in that area. And so one of the layers that NASA has produced is population estimates for particular areas. And so you can use those estimates of who's living or the number of people living in an area, overlay that with these places that we're seeing changes, and help to sort of understand who's being impacted, maybe some of the decisions that go to why things are happening in particular areas. But first, it all goes back to that map of just where are things changing before we can really get into some of the questions about the impacts of those, and in particular, future scenarios. You know, thinking about climate change, thinking about that interaction between surface temperature and our trees, right? And so it is a really big concern about where changes are happening, where deforestation might be happening, and who is impacted by these events that are out there.
One of the many articles that I've read recently, and it's actually quite accessible topic, is people reforesting areas, in part because of the need to absorb some of the excess carbon in the atmosphere. But coal mining areas in Kentucky are actually trying to revegetate some of the areas that have been strip mined in order to make their local environment more livable, essentially stabilizing the landscape and trying to bring back a more sustainable type of economy that isn't so destructive to the landscapes. So that's just one of the many stories that you'll find where people are going, we should be planting more trees. A little farther afield, a colleague of mine who works at the Danish Geological Survey, well, it's GEUS, I can't actually pronounce how they say it, but is planting 5,000 trees in southern Greenland because of the close association between Denmark and Greenland. And when you think about how challenging it is to keep trees alive even here in Maryland, you can well imagine the challenges of trying to grow a forest in Greenland, even southern Greenland. And one of the little side stories I can contribute is when US Army personnel were stationed on the west coast of Greenland at a place called Sandøy-Stormfjord, there was an Air Force base there, and they went outside the Air Force base and they planted trees up the fjord away from where they were living. And so because of the very short growing season there, those trees are literally a few feet high, but they are species that you'd be familiar with because, like us living here in Maryland, people took what they knew and took it to Greenland with them. And so it's just kind of a, you know, you're walking along the Outwash Plain coming down from the glacier coming off the side of the Greenland ice sheet, and you go, oh my God, that is a tiny little oak tree. It's amazing when you see them.